Okay, the last video for this section, we're actually going to try to do what we did method number 1 for solving a quadratic equation. We want to do that backwards. You know, completing the square was kind of doing the binomial formula backwards. This is doing factoring backwards, which is a little bit strange, but once you get used to it, it's pretty easy. So it says find a quadratic equation, so that'll be degree 2 equation, right? Equation means equals 0, not equal y, not equal f of x, and not just the polynomial, equals 0. Don't leave that off. So find a quadratic equation with the given roots. Remember, roots are also called zeros. They're the numbers that you plug into a polynomial to give you 0. In other words, they're solutions of a quadratic equation. So they're giving you the solutions to a quadratic equation and asking you, what the heck is the equation that these are the solution to? Okay? So these are the 2 steps. Well, there's 3 actually. The way that your text wants the answers written, there's a 3rd step. But it's not necessary in theory, but I think that they want you to do that 3rd step anyway. So the first step is they're going to give you they're going to give you the roots, which you can write as equations. X equals, right, the root. X equals the second root, like that. Those are linear equations. The highest power of x is 1. Right, and so you put those in standard form, and then you multiply the equations, right? And multiplying the equations will mean actually taking one, writing down times the other. But then your text wants you to actually take those and multiply them out and simplify, so that it's not in factored form. Okay, so examples. Suppose that your roots are 2 and minus 3. I suppose I should have written this part out too, because sometimes they'd say your roots are x equals 2 and x equals negative 3. Sometimes they'll just say the roots are 2 and negative 3. And you have to know to write down x equals 2 and x equals negative 3. Okay? Those are linear equations. They're first degree polynomials. Right? You're going to write it as a polynomial equation, which remember is equal to 0. So the first thing I would do is I would, get all of the non-zero terms on the left side or the right side, whichever is, I would put it on the left side on these always. So you get x minus 2 equals 0. And x plus 3 equals 0. The left side of these 2 equations are going to be your 2 factors for your polynomial. So you just write the 2 factors times each other, see? So that first step is really important. People get confused if they don't do that first step, especially if the number on the right side of the original, if the root is more complicated, like it could be 5 minus I, or 5 plus square root of 3, right? And so if you just write it with a 0 on the right, as a polynomial equation, actually a linear equation, then you just have to take those to the left side of each equation and just multiply them. Of course, they're binomials, so you need parentheses for both of them, right? And that's really the answer right there. That's a quadratic equation with the roots that they wanted. You can check it. Just plug the 2 in. You obviously get 0, right? Take this 2, plug it in here. You get 0. Take the negative 3, plug it in here. You get 0, right? But they want you to multiply this out. So you just get what? You get x squared. Then you get the inside and the outside, the 2 x terms, right? So you get 3x minus 2x is x. So you'll get x squared plus x, and then minus 6 equals 0. Don't forget the equals 0. It'll mark you wrong if you don't leave the 0 off. They asked for a quadratic equation, not a quadratic. Quadratic would be x squared plus x minus 6. A quadratic function would be x squared plus x minus 6 equals y. A quadratic equation is x squared plus x minus 6 equals 0. And you'll probably mess up some of these, but just try to remember to put the 0 in there. Okay, we're going to do another example. I'm going to do, I think, 2 more examples. This one's with the square root of a positive number, and the other one will be with a complex number, a non-real complex number. In other words, with the square root of a negative number, which works exactly the same. Okay, so here I want these 2 roots. And again, they might not have said z equals. They could have just said, you know, the roots are 3 plus square root of 2 and 3 minus square root of 2. Now these, you might suspect, will work out nicely because those happen to be conjugates of each other, right? 3 plus square root of 2, 3 minus square root of 2. Those are conjugates, which means probably my final answer won't have square roots in it. Okay, so I just, right? Some people call this solving for 0, which is actually not actually correct, but you're just getting all of the non-zero terms on the left side. So you subtract 3 from both sides, you subtract negative 2 from both sides, or just take the 2 terms, move them to the left and make them negative. But remember, you're left with a 0 on the right. Don't lose your equation, okay? And then do the same thing with the other one, right? Notice how they're slightly different. They both have a minus 3, but the sign of the square root of 2 is different. Okay, and then I'm going to take these 2 left side of these. These are actually trinomials, right? The left side, well, you can think of it as a binomial if you think of the 2 constants as part of the same number, I guess. But you put parentheses around the left sides, and you multiply them. And now you just have to multiply them out. Now, how do you multiply 3 terms times 3 terms? Well, it's actually the exact same rule as before, as long as you're not thinking this stupid FOIL thing. Forget that, okay? What you're doing is you're taking each of these 3 and multiplying them by each of these 3. So that's pretty straightforward. So if you just want to do this longhand without being clever or anything, you would just take z times z, that's z squared, z times minus 3, so it's minus 3z, z times square root of 2, and then you're going to take negative 3 times negative 3 is 9. Negative 3 times square root of 2 is negative 3 square root of 2. Oh, wait, I skipped one. You have to take negative 3 times all 3 of these. And then you take negative square root of 2 times all 3 of these. And then you combine like terms. I probably took a bit of a shortcut here. No, I didn't. I took z times, so what I'm doing here is I'm taking, I'm just doing it the way I just said. I'm taking this z times all 3 of these. That's what this is. And there's more. There's going to be 9 terms altogether. So now I'm taking minus 3 times each of these. And that's what these 3 are. Okay. And then I'm going to take the minus square root of 2 times each of these 3. And remember, minus square root of 2 times square root of 2 is just negative 2. So I'm going to do those. And just be careful about this because it's easy to mess it up. And then you combine like terms. So there's only one term with a z squared in it. That's this one. So this is going to, oh, this should be equal 0. Don't forget the 0. There, see? Okay, now we're going to, the z squared is the only square term. Then we have to put together the z terms, but you might be worried about putting these together, but notice there's a square root of 2z, and there's a minus square root of 2z. So maybe we should just cancel off things that subtract out first. because all of these, the thing is, because these were conjugates, I actually know that all of these things with square roots are going to cancel out. Look, see, 3 square root of 2, negative 3 square root of 2. So those cancel, right? So just kind of do that. Those two cancel. Those two cancel. Then what? The minus 3z and the minus 3z don't cancel. That gives you minus 6z, right? These two. And then the 9 minus 2 is the 7. So that's it, right? And that's what they want for your answer. See, that one simplified a lot. We went from 9 terms down to 3. Okay, now we're going to do one last example. And this is, I just wanted to do one where the roots are non-real complex numbers. So, and notice I made them conjugates again. Why? Because if I make them conjugates, what will happen is the same thing that happened on the previous example is you end up getting an answer. Here you end up with an answer with no square roots in it. And that's because these were conjugates. If I make these complex conjugates, right, then the final answer, when I multiply it out, it won't have any i's in it. If this was something else, like say this was 1 plus square root of 3, my final equation would have i's in it. So first I'm going to just take and rewrite each of these. This is the critical step. If you do this step, it's easy. The rest of it is just pretty basic algebra. Okay, so you write, what did I do? Subtract the 2, right? Subtract the 2 from both sides. Add the 3i to both sides, right? Or in other words, take these two terms, move them to the left side, you get a negative 2 and a plus 3i. And on the right, you have a 0. Don't forget it's an equation. It equals 0. Same thing here. It's going to be y minus 2 minus 3i equals 0, right? Then put parentheses around this one, and multiply the 2, and what we get? 0 times 0, 0, right? Same as we did in the last one. There you go. And then we have to multiply this mess out. And again, you're going to get 9 terms. You do it the exact same way you did the last one. Just remember that I times I is minus 1. Actually, you'll get a I times a negative I, which is 1. So that's nice. So that's the first 3. It's just y times this y times all 3 of these, right? And then I'll do this negative 2 times all 3 of these, right? Be careful of signs. If you get the signs wrong, any of these signs wrong, you're going to get the wrong answer. There's a lot of signs. So the 3i times y is 3iy, duh. The 3i times negative 2 is negative 6i. The 3i times minus 3i. Remember, I times minus I is 1. So this is just 3 times 3, which is 9. Be careful of that one. If you need to, write out the middle, the intermediate step of minus 9i squared. But remember, the minus I squared is 1. Okay, and then things will cancel out. Some things will cancel out. Equals 0. Don't forget the equals 0. Some things will cancel out. Right? Plus and minus of the same thing. Plus and minus of the same thing. Look familiar? They're even in the same places as on the previous problem. And then the minus 2y is minus 4y. Don't cancel those. Right? And the 4 plus 9 is 13. Equals 0. Again, don't forget the equals 0. That's the number one thing. People get through all this stuff and then they forget the equals 0 at the end. You could write the equals 0 first when you first start the problem. Just enter equals 0 online and then figure out all the rest of the stuff and then write the polynomial in. Because you don't have to have 0 on the right side, right? Just write, yep. So just write the 0 first. That's what I usually do. If there's something simple that I think I'm going to forget, I do that simple one first. Okay, that's it for that section. Sorry if that took a little while, but I just want to make sure that you get these. None of this stuff is all that hard, but you have to practice it and make sure you got it down before you take a test on it. Okay, so I'll see you in the next section.